In this video, we are continuing our discussion on the Lineweaver-Burk reciprocal plot. To make things easier for you, I suggest that you watch the previous video. Okay, so we are given this set of data and then we are required to determine the values of Km and Vmax. Okay, so we said that the Lineweaver-Burk reciprocal plot is characterized by the equation of a straight line. And it is given as 1 over v is equals to the Km value over Vmax multiplied by 1 over the concentration of the substrate plus 1 over Vmax. So this represents the y values. This is going to give us our gradient. This is going to give us the x values, and 1 over Vmax represent the y-intercept. So as you can see, we have the inverse of the velocity, and we also have the inverse of the concentration of the substrate. For this data, we are given the substrate concentration. So we need to find the inverse for the concentration of the substrate. And we also need to find the inverse for the velocity. Okay, so we need 1 over the concentration of the substrate, and then the units are not going to change. Also, we need 1 over V. Okay, so in order to find the reciprocal value, you're just going to say 2.5 to the exponent of -1. So this gives me 0.400. And then this is just going to be 1.000. And then 0.714 to the exponent of -1, 1.401. And then you're just going to do the same thing for the rest of the values. Okay, and then once you are done, you are going to plot. So on the y-axis, you're going to have 1 over v, and then on the x-axis, it's 1 over the concentration of the substrate. So now I'm not going to plot the values, but when you do, your straight line should look like that. It will always look like that. Okay, where on your y-intercept, you're going to have 1 over Vmax, and then on your x-intercept, you will have -1 over the Km value. Okay, so I'm going to teach you now how to find the equation of the straight line using a calculator. So you will press mode setup, you will choose option 2, which is stats, and then you will choose option 2 again, which is a plus bx. And then now you're going to input your data. This will be the x values, and on the right hand side, these will be your y values. 0.4, 1, 1.401, okay. And then when you are done inputting your data, you will press AC, then you will press shift, you will press number 1, and then you'll choose option 5, which is regression and analysis. And then you will see a list of variables, and then you'll choose number 1, which gives you the value of A. So A is equals to 1.467, and then you'll do the same thing again. Press AC, shift 1, 5, number 2. This is going to give you your value of B, which is 617. Now you have the equation of the straight line, which is y is equals to 0.617 x plus 1.467. Okay. So the reason why we do all of this, it is for us to be able to calculate the Vmax value as well as the Km value. So you can see that on the y-intercept, we have the reciprocal of the Vmax. So this is what you're going to do. You'll say 1 over Vmax is equals to your y-intercept. So this is 1.467. So the Vmax value is just going to be 1.467 So 1.467 to the exponent of -1. This gives me 0.682. And then the units are, okay. And then in order to find the x-intercept, we're just going to use the equation of the straight line. 617x plus 1.467. So you can see that the reciprocal for the Km value is on the x-intercept. So for the x-intercept, you set y is equals to 0, and then 0.617x plus 1.467. So the x value is negative 1.467 divided by 0.617. So I am getting negative 2.378. And then this is negative 1 all over the Km, which is equals to negative 2.378. Therefore, the Km value is equals to 2.378. So I am getting 0.421, and the units moles per liter. Okay. Now let's just say that you don't have a calculator. For those of you that are going to use the calculator, you can close the video now. If you don't have a calculator, you will just have to use 2 points on your graph. And this is going to give you the gradient. So this is Kmax. It's Km over the Vmax. That's what the gradient is. So the gradient is equals to Km over Vmax. And then we know that the gradient is the change in y over the change in x. For simplicity, I'm not going to use the graph. I'm just going to choose 2 random points from the table. So I'm going to choose 3.906 minus 2.701 all over. The corresponding x values is 4 and 1.901. Okay, so this is 3.906 minus 2.701 over 4 minus 1.901. And then the gradient is 0.574. and then y is equals to 0.574 x plus c, and then you're just going to substitute a point. So I'm going to choose 0.574. This is 0.4 plus c, and then the y value is 1.701. So my y-intercept is 1.701 minus 0.574 multiplied by 0.4. So this is 1.4714. So the equation of a straight line is 0.574 x plus 1.471. Okay, so we said that the y-intercept is given by 1 over Vmax, which is 1.471. So Vmax is equals to 1.471 to exponent of n. So this is 0.6798. Okay, and then now we're just going to find the x-intercept. So negative 1.471 divided by 0.574. So I'm getting minus 2.562. Negative 1 over Km is equals to negative 2.562. Therefore, the Km value is equals to I am getting 0.390 moles per liter. So the values, they won't be exactly the same, because when you use the calculator, you're going to get a more accurate answer than when you do this manually. But yes, that's how you find the Vmax and the Km values.